Picture this scenario. You arrive at the office with your fresh cup of coffee. You open up your email. You open up your ticketing system. And all of a sudden you see a whole bunch of messages. And one of them says that so-and-so, let's say PC1, can't reach the internet or their favorite website or whatever it happens to be. It's pretty vague, but you'll go through the troubleshooting flow that you have come up with over your career. And one of the very first things you'll do is verify the problem using ping. So you'll access the client's PC. You'll probably go to it, and you'll execute a ping. And the ping fails, therefore verifying the problem. But now, what should you do next? You need to determine if the client's addressed appropriately, or if they even have an IP address. And you can do so using commands such as ipconfig, or take it a step further and use the command ipconfig all. So with ipconfig, we are just getting a brief snapshot of some of the most fundamental addressing. For example, your IPv6 link local address, your IPv6 global unicast address, your IPv4 address, your subnet mask, your default gateway, all values that we'll need to verify before we even start to troubleshoot. And you may ask, well, why, Raymond? Why do I need to worry about these? Well, here's the thing you need to realize. Let's say the client is configured to obtain its IP address via DHCP. Well, how would you know that? Well, you could use ipconfig switch all in order to accomplish that, as we see right here. You can see that it's DHCP enabled. So it's going to seek out that DHCP server to receive its addressing information. Well, what happens if it's not able to reach a DHCP server? Well, if auto configuration is enabled, it will automatically configure an IP address. And the IP address is a 169.254.x.x. So .x.x simply means it could be any value in the last 2 octets, and it's going to be a /16 subnet mask. This is known as an APIPA address. APIPA, automatic private IP addressing. So the client automatically gives itself an IP address because it cannot find a DHCP server to provide one for it. This right here, the fact that you have an APIPA address, is a good sign that the client has issues at layer 2. It could be physical connectivity to the switch that's the problem. It could be VLANs that's the problem. It could be trunks that are pruning VLANs. It could be port security that's the issue. All of that falls into our layer 2 category of troubleshooting. But if you receive an IP address from your DHCP server, then there's a good chance that the problem is elsewhere within the network. It's not in that layer 2 environment that the client's part of. So it's a great place to start and just verify, do we have an appropriate IP address on this client? Using the ipconfig commands. Notice you'll also be able to verify the MAC address. Now, why do you care about the MAC address? You care because this is the address that switches will populate their MAC address table with. So if you're trying to verify which client is connected to which switch port, you can look at the MAC address table on that switch. And then you can compare the MAC address learned on a port with the MAC address of the client itself using ipconfig/all. And by doing so, you can therefore, without a doubt, 100% be confident that that is the correct device connected to that switch port. Unless we have security issues in our environment and somebody spoofing MAC addresses. But hopefully we have mechanisms in place to prevent the spoofing from occurring. But what else can we see here in this output? We can see, again, the link local IPv6 addresses. We'd be able to see the global IPv6 unicast addresses as well. We can verify our IPv4 addresses, our subnet mask. We can also verify when the lease was obtained and when it expires for DHCP, the default gateway, who the DHCP server is, as well as DNS servers. So if a client is experiencing issues with name resolution, this is a great place to see if they're actually receiving the IP address of the DNS servers from the DHCP server. If you prefer to use the graphical user interface for verification, you can do so as well. Let's take a look at that. We'll go to PC1 in our topology, and on PC1, we'll bring it up. Let me open up the graphical interface here. We have PC1 status. We'll click on properties of our network interface card. So we're at the properties of the network interface card right now. Open that up. We'll see here for IPv4, the properties. We are configured to obtain an IP address automatically via DHCP. If we were to configure manual address assignment, we do so right here. But we'll stick with the DHCP option here for IPv4. And for IPv6, it'd be right here, right above it. There's the TCP/IP version 6 protocol stack information. Right here, the properties, again, obtaining an IP address, IPv6 address via DHCP, or SLAC, stateless auto configuration. And here, if we need to, we can configure one manually. So very important commands and very important areas of our PCs that we want to be able to navigate and verify if they are appropriately addressed. So let's examine again PC1 using the ipconfig command, and we can see its IPv4 address is 10.1.1.10. There's its default gateway for both IPv6 and IPv4, subnet mask /26. So we can see here that PC1 being in VLAN 10, VLAN 10 is the 10.1.1.0/26 network. We do have an address, 10.1.1.10, that falls within that range, and it is using the appropriate subnet mask.